Hello and welcome back to the Arduino Python series, and this is the tutorial number 20, a milestone. So today we're building a practical and potentially life-saving project, a fire detection alarm system. We will use a flame sensor to detect fire, a buzzer for audio alerts, and RGB LED for visual warnings, and a relay to connect external devices like if you have sprinkler or if you have an exhaust fan, so you can connect them directly to the output of your relay. We will also add a confirmation delay to avoid false alarms and a keyboard to reset to manually silence the alarm. So when the alarm just start, uh, someone have to go and reset it manually, uh, so it won't just stop by itself. You have to stop it manually. By the end of this video, you will understand how to create a reliable alarm system with debouncing, state management, and user interaction, all controlled from Python. Let's get started. So for today's project, we need an Arduino board, a flame sensor module, a relay module, RGB LED module, or if you don't have module, you can use three different colored LEDs, but don't forget to use resistors if you're not using a module. Passive buzzer, or again I am using a buzzer module, but again if you don't have buzzer module you can use buzzer. It's not a problem, that's okay. Breadboard and jumper wires, and if you want to connect a DC motor or something else to your relay, just make sure that you have a 12 volt external power supply, but it's not compulsory, and it's completely optional, because in today's project we won't just connect anything to our relay. So if you don't have the power supply module, it's completely okay. Okay guys, let me explain to you how you can set up your hardware. So this is my flame sensor or flame module, and if you can see here, there's a small knob here. Okay, so if you just turn it, you can just adjust the sensitivity of your sensor. Okay, and you can see there is a 4 pins on your module or on your sensor. Okay, so the first pin here, it's for analog read, and this is the G, and this is, so go for the GND or negative, and this is the 5 volts, and this is the digital output that gives you 0 or 1. So today we're gonna use only the digital output. We just ignore the analog output. Okay, so how I'm gonna set it up, I'm gonna just put it here just like that. Okay, so I'm gonna start wiring it. So the digital will go to pin number 2 of my Arduino board. Okay, so the digital pin is the first pin, if you can see. Okay, so the first pin goes to the pin number 2 on my Arduino board. 0, 1, 2. Okay, just be careful because the pins on your Arduino board are very near together. They're next, so you may make a mistake. And the next one is the plus or the positive. Okay, so I'm gonna connect it. I'm gonna connect the positive pin to the positive section of my breadboard. Okay, and the next one is the GND. Okay, so I'm gonna connect the GND. Okay, I'm gonna connect it to the negative side of my breadboard. Okay, the next one is my buzzer module. So my buzzer module has 3 pins, but don't worry guys, if you don't have the buzzer module, you can still use the normal buzzer. I just use it to show you that if you have the user module, you can use it. So the first pin is the negative, the second is the positive, and the third one is the signal pin. Okay, so how I'm gonna install it? I'm gonna just install it by my flame sensor. Okay, just like that. So as I told you, the first pin from here, so the buzzer goes to pin number 9. Okay, so from here it goes to pin number 9 on my Arduino board. Okay, and the second pin is the 5 volts. Okay, so I'm gonna connect it to the positive of my breadboard, and one more left. So the last pin is the negative 1, so I'm gonna connect it okay I'm gonna connect it to the negative okay of my breadboard. All right, now the next module is my RGB module. Okay, so this is exactly like the previous lesson. So the first one is negative, and for the red, green, and blue. Okay, so I'm gonna connect it here by my buzzer module. Okay, so the first pin is the negative. Okay, so I'm gonna connect it to the negative side of my breadboard, and the next one I'm gonna connect the red to the pin number 5, okay, of my breadboard. So it's gonna go to the pin number 5 of my breadboard. Of my Arduino board. Sorry, I made a mistake. So it goes to the pin number 5 of my Arduino. Okay, now the next one is the green one. Okay, all right, so the green also goes to pin number 6 of my Arduino board. Okay, goes to the pin number 6, and the blue one goes to pin number 7. Okay, the blue one goes to pin number 7. Sorry. Okay, so it goes to pin number 7. And one more thing left, my relay module. Okay, so I'm gonna connect it again here, and the pins. Okay, so the first pin is the signal, the middle one is the positive, and the last one is the negative, or the GND. So I'm gonna connect it I'm gonna connect it here just like that. Okay, so the switch of my relay goes to the pin number 8. Okay, so this is the last pin of my okay, so it goes to pin number 8. Okay, pin number 8, right? And the next one, so as you can see, the middle one is the positive. Okay, so the middle one is the positive, so I'm gonna connect it just okay, so I'm gonna connect it to the positive section of my breadboard, and the last one is the GND. Okay, so I'm gonna connect the GND to the negative section. Okay, and only two things left. Okay, now I have to connect this 5 volt and the GND of my Arduino board. I have to jump them to my breadboard. Okay, so I'm gonna just connect them like this. So the 5 volts go to the positive and the GND goes to the negative part of my breadboard. Okay, so this is the wiring and setting up the hardware of the today's project. So now we can go and start coding. Now let's start coding. So at the beginning I'm going to just create a new file and I'm gonna call it, for example, like fire alarm.py. Okay, and the first step for coding is we have to import our libraries, and again today we're gonna use PyFirmata like the previous lessons, like the two previous lessons. So I'm gonna say from PyFirmata import Arduino and util. Okay, and I'm gonna just import time, and again today I'm gonna import keyboard. I'm gonna import our keyboard library. Okay, because we want to use it as a reset button. So now I have to set the correct serial port. I'm gonna say port. So which port I am connecting? I'm connecting through port 9, but make sure that you change it to your port. And I'm gonna say port equal yes, Arduino. So I'm gonna just use my Arduino library, Arduino. Which port my Arduino is connected through? Connected through this port. Okay, the next step is to just start the iterator. I'm gonna say iterator and created a variable. Okay, and I'm gonna use our utility library. I'm gonna say util.iterator. Okay, so where I want to use this iterator should just start from here at my Arduino board. So I'm gonna say board. Okay, now I have to start my iterator. I'm gonna say iterator dot start, open and close parentheses, and a small delay. I'm gonna say time that sleep, like let's say what, because we're gonna wait 1 second for everything to initialize. Okay, now the next step is to define our pins. So again today, if you can remember from the previous lesson, our tilt switch was the only input in that project, and today we also have only one input, and this is the flame module. So I'm gonna say flame. I'm gonna create a variable. I say flame. And how I can define the pins now, all of you know. So I'm going to say board that get pin. Okay, so this is digital pin number 2, and as I told you, it's input. Okay, so the flame module is the only module that we use as an input. The next one, I'm going to define our relay, and I'm going to say board dot get pin. Okay, so again it's digital pin number 8, and all of them, again all the other modules, they will be output, so we're going to use them as an output. Okay, so I can just connect this line, I can connect it, and I can just sorry, I can copy this line, and I can paste it for the other, pins and modules. So the next one, I want to just define our buzzer module. I'm gonna say, but the only thing that I have to change is the pin number. So the buzzer connected through pin number 9, and again as an output. Okay. So the next one, now we have to define the three LED colors that we have in our module. So first I'm gonna start with the red. I said red board.get pin, but pin now I'm using pin number 5. Okay, now I'm gonna define the green color, and I say board.get pin. Now I'm using the pin number 6, and the last one is the blue color, so I'm gonna use it as pin number 7. Okay, all of them, just check, all of them should be output, but the flame module should be input. Okay, and the pin numbers 2, 8, 9, 5, 6, 7, we just double check to not use one pin 2 times or more than 1 time, because we're gonna just see an error. Okay, now I want to tell my program that for example, if the sensor detected the flame for like 2 seconds or 3 seconds continuously, then trigger the alarm. Why I want to do this? Because it will prevent the false triggers from momentary flashes. Okay, so if we do not just do that, so it may just trigger the alarm with even a short, a very small, like heat or flame. It's not a real fire or not a real flame, but it will trigger the alarm. So we have to tell the program to trigger the alarm just when, for example, you sense the flame for 2 continuously seconds. Okay, so now how I can do that? I'm gonna say, for example, I'm gonna call this variable as a variable like fire confirm duration. Okay, so fire confirm duration, for how I'm gonna give it, for example, like 2 seconds. Okay, you can just give it another, if you want it to be sensitive, you can give it 1. I just give it 2, but if you want, you can just give it even more numbers. It completely depends on you, but for now I'm gonna give it 2. And one more time, for I want to tell my because when the alarm trigger, the red LED, we say we want to just turn on, but we want to say to define the blink intervals, the seconds for LED blinking. So now I'm gonna create another variable. I'm gonna call it like blink interval. I'm gonna say like 0.5 seconds. Okay, so blink interval is the half period for the blinking the red LED during a fire. Okay, now exactly like the previous lessons, if you can remember, uh, we just created a function for our for the LEDs, a simple function to set all 3 LED colors at once. So when we pass 0 or 1 for each, we could just easily turn them on and off instead of doing it manually. So we are doing it inside of a function. So I'm gonna just create another again create a function like the previous lessons. I'm gonna say def I'm gonna call it set RGB. Okay, so how many arguments I have to pass it? I have one R, G, and B, because I have red, green, and blue LED. And I'm gonna say red dot right. Okay, I'm gonna give it the R argument, and I'm gonna say green dot right. I'm gonna pass it the G, and I'm gonna say blue dot right, and I'm gonna give it B. Okay, so this is for our RGB LED module function. So now we have to define another function for our safe, state, for when for when we don't just detect any fire or any flame, and when everything is normal. Okay, and we're gonna define another function for when our flame sensor detect a fire or detect a flame. Okay, first I'm gonna just define for the normal condition. I'm gonna say def, and I'm gonna call it like safe state. Okay, so no need for the argument in these two functions. Okay, so in this function I want my green LED to be on and buzzer and relay to be off. Okay, so I'm gonna say set, I'm gonna call this function, I'm gonna call my RGB function that I defined here, set RGB, and I'm gonna just turn the red LED off, turn the green LED on, and turn the blue LED off too, and I'm gonna just turn my buzzer that right off, so I'm gonna give it 0, and I'm gonna say relay that right, I'm gonna give it 1, because if you can remember, uh, when we wanted to turn our relay off, we should have give it 1, and when we wanted to turn it on, uh, we should have give it 0. But again, one more time, I told you in that lesson too, but it depends on the kind of relay that you're using. Maybe sometimes you need to put it 0 exactly to make it off, and sometimes you need to put it 1 to make it off. So you have to check it inside your program. Okay, now let's create another function for when our sensor detect a flame or fire. And I'm gonna say def, and I'm gonna call it like fire state, but this time I'm gonna because at this state, at this condition, we want our red LED to start blinking. Okay, so that's why I'm gonna just give it an argument. I'm gonna call it blink on. Okay, so this is one argument, and I'm gonna just again call my RGB function. I'm gonna say set RGB. Okay, but this time for the red LED, I'm gonna use this argument. I'm gonna say blink on. Okay, and the green should be off, and the blue also should be off. Okay, and I'm gonna say I want our buzzer and relay, both of them on as well. So I'm gonna say buzzer dot right, sorry, 1, and relay dot right. So that time in this function I set the relay 0 to put it off, and here I'm gonna just give it 1 to turn it off. But again, one more time, I tell you, now in this project we assume that the relay active high, but we can adjust if we need it. So it depends, kind of your relay that you're using, if it's active high or active low, but you can check it during running the program. So it's completely okay for now. Okay, so this is our functions. So 3 functions we defined here. Now it's time to just create our main loop. Again, I'm gonna just start to create our main loop with try block to catch a keyboard interrupt later. Okay, so I'm gonna say try. All right, so here, I have 2 mode in this program, safe or fire mode, and I have to track whether we are in safe or in fire mode. So I'm gonna create, a variable. I'm gonna say system safe to just I created this variable to track, my whether I am in a safe or in fire mode. That's why I create this variable. So I'm gonna say safe system. I will say save. Okay, I call it save. Now another variable, I need to store, the timestamp when the flame was first detected. Okay, so it used to measure the confirmation duration to use this. Okay, so I'm gonna create another variable. I'm gonna call it last flame time. Okay, and at the beginning I give it none, because at the beginning we don't have anything, we don't know anything, so I just give it none, but later we will update it. And we're gonna just create one more variable for the time when the fire detected and the red LED start blinking, because it has to give us true or false. So if it will be true here in this function, the red LED will start blinking, and if it gives us false, the LED will just go off. Okay, so I'm going to create another variable. I'm going to call it blink state, and I'm going to give it true. Okay, so I gave it true. After creating these three variables, I'm gonna just call my save state function just to set the initial outputs and print a ready message after that. Okay, so I'm gonna call I call my save state function, open and close parentheses, and I'm gonna print a message for the user or operator. I'm gonna say like system ready. Okay, system ready, and I'm gonna call it like for now it's save. Okay, so this is our try. For now it's time for creating our infinite loop. So as usual, I'm gonna say while true is true. Okay, so now I have to read the data from our flame sensor. How I can do that? Because if you can remember, because if it's input, okay, because I have to read the data from this sensor, I can say flame dot read, open and close parentheses. Okay, but because later in the programming, in the coding, I want to use this flame dot read. Because I want to make it easy for myself, I'm gonna put it inside a variable. So I'm gonna call this variable like flame val. So I put this flame that read inside this variable. So flame val equal flame that read, and if you can remember here, fire confirm duration. So we also have to just calculate the time that for how long, for example, this flame is detected. Okay, so we have to just get the current time. Okay, so I'm gonna call it the current time, and I'm gonna use our time library that we imported at the beginning. I'm gonna say time, but you don't pass it any value. Okay, so but what if my sensor, this flame that read, what if it doesn't read anything? Okay, what if for example at the beginning, maybe for example our iterator hasn't received any value? So what is gonna happen? The program just send us an error. Okay, so we have to just tell our program like if flame val is none, then what it should do, just time that I'm gonna say just wait a little bit. Okay, 0 point very tiny stop. Okay, time that sleep 0.05, and after that just continue. Okay, so if the reading is none, we wait a bit and skip the rest of the loop. Okay, we won't go to the next line, because if it goes, it will just send you an error. but we say continue. So if you don't read anything, just skip the rest of the loop. Now we have to create this state transitions. This is where the system decides whether to go from safe to fire based on the flame sensor readings and a confirmation timer. Okay, so I'm gonna use if statement again, and I say if system state is not equal to fire. Okay, so if system state, okay, I don't know if oh, I made a mistake here. System, I just made a mistake. Instead of system safe, I should have say a system state here, guys. I'm so sorry. I just made a mistake. System state. This variable, just make sure that you correct this. So system state. Now I'm going to use this variable here. So I'm going to say if system state is not fire. Okay. So do what? But what do I mean by if system state is not equal to fire? This line ensures that we only attempt to transition into the fire state when we are not already in fire. So once we are in fire, we don't want to keep checking for flame detection again. The fire state has its own behavior, like as I told you, the red LED will just blink, the buzzer and the LED and the relay are on, and this separation keeps the logic completely clean. Okay, so if we are in safe or any other state, but we only have safe and fire, we proceed. Okay, but if we are in fire states, we don't do anything. And just again one more time, I made one more mistake here. So just fire, just everything should be in capital. Okay, so now in the next time, so what should we do next? Now let's say if the sensor indicates a flame is present. Okay, so again we're gonna use another if statement. I'm gonna say if I'm gonna use this flame valve variable, this because I want to read the data from my sensor. So I'm gonna say if flame valve, so if flame valve, so far I just say if it detects a flame. Okay, so if flame detected. Now I created this variable here. I said last flame time. Okay, so I'm gonna say here, I'm gonna say if last flame time is none. Okay, so we have a variable, we have this variable last flame time here. We defined it, we set it to none at the beginning. So this variable, it stores at the moment when we first saw the flame. It starts as a none. When a flame is first detected, we set last flame time equal to current time. Okay, so how I can do that? I'm gonna say last flame time equal to current time. Okay, so this current time, this variable that again I created here. Okay, so this records the state of the potential a fire event. But again, why do we need this? As I told you, because we don't want to trigger the alarm on a single momentary flash. It could be a false alarm, like example, a reflection or a quick spark. So we wait for the flame to be present continuously for a certain duration, and then we just trigger our alarm system. But what if the last flame time is not known? Okay, what if this variable is not known? Okay, it means that we have already seen a flame before. So we have to calculate how much time has passed since that first detection. Okay, So I'm gonna create an elif, loop. I'm gonna say elif, okay, elif, and okay, elif. Just I'm gonna continue it here. Elif. Now I say current time minus last flame time. If this, if the current time minus last flame time, if that difference is greater than or equal to our confirmation threshold. Okay, this variable here that we defined, this one, fire confirmation, this fire confirm duration. Okay, if this one is greater or equal to this threshold, that I said we set it to 2 seconds, then the flame has been present long enough. It means a real fire has happened. Okay, so I'm gonna say if this is greater or equal, then the fire confirm duration. Okay, so what gonna happen at this time? As I told you, it means that the real fire has happened. So the system state will be to fire. Okay, and we're gonna print a message. I'm gonna say print like fire emergency detected. Fire emergency detected. Okay, so but now here, okay, so this part is finished. But what if the flame valve? What if the the data from the sensor? Okay, this current, flame that read. What if this variable is false? It means no flame detected. Okay, so now here we have to create another else. Okay, so I'm gonna create this else here. I'm gonna say, oh sorry, else. Okay, we're gonna create an else. Okay, so I'm gonna say we want to reset the last flame time back to none. Okay, so this clears the timer. So if the flame reappears later, we will continue from scratch. Okay, so how I can do that? I'm gonna say if else last but this no, see, we made a mistake here. Okay, this elif, the elif should be under this the elif should be here. Okay, because we were just yes, it's if, and if last flame time is none. Yes, okay, so the elif should be here, and now we're gonna just define our else here. So I'm gonna say else, I'm gonna say last flame time, if this will equal to be none. So here we reset the last flame time back to none. This clears the timer, as I told you, and if the flame reappears later, we will start counting from scratch, right? But now I'm gonna just so last flame time we set it to none. So what else we need? Oh, okay, so now I need to say if system state is not equal to save. Okay, then what gonna happen? But guys, why I just wrote this code, if system state is not equal to save? In our current design, when we are in this branch, okay, and system state is safe, this condition is false, so nothing happens. But if for some reasons we were in a different state, like a hypothetical test state, and the flame disappeared, this would revert to safe. Okay, so it's a safety net to ensure that if the system ever gets stuck in a non-safe, non-fire state, it will return to safe when no flame is present. Okay, even in practical, with only two states, this line is redundant, but it's good practice for future expansion. So I can say if system is not equal to safe, then what gonna happen? Just stay in the safe state. So I'm gonna say system state equal to safe. Okay, and at the end just print a message for the user and for the operator. And I'm gonna say safe state. Okay, so safe state, right? So now this is our just state transitions part. Okay, from for example safe to fire, and I don't think anything's left. But maybe you're gonna ask yourself, why we made this design. Okay, this state transition logic provides, debouncing and confirmation to avoid false alarms. It also ensures that, once a fire is declared, the system stays in alarm mode until manually reset, until someone goes and, manually reset the system. Okay, which is standard for emergency systems. It's an international standard. So by separating the transition logic from the action logic, what happened in each state, the code becomes, modular and easy to modify. Okay, now we have to define our system states. Okay, so now I can say if system state equal to safe. Okay, so what's gonna happen here in this mode? So we're gonna just call our function, our safe state function. Okay, so I'm gonna say don't forget about the colon, because we're using the if statement. So if system states equal to safe, then what's gonna happen? We're gonna call our safe state function. Okay, so yes, this is for the safe state now. But what if we will not be in the safe state? Okay, so what gonna do at that time? Now we're gonna use just elif. So I'm gonna say elif system state equal to fire. Then what gonna happen? Okay, when the system is in fire state, okay, we want the red LED to blink continuously. For example, half a second on, half a second off. We also need to keep checking the flame sensor and listening for the, R key, or whatever key that you define on your keyboard to reset. So if we use time.sleep inside the loop, the program would freeze during the sleep and miss sensor reading or keyboard presses. So we need a non-blocking way to toggle the LED. We defined the blink interval here. If you can check, where is the blink? Okay, see, we defined the blink interval equal to 0.5. This is the duration in seconds that the LED stays on or off during one half of the blink cycle. So the full blink cycle, on plus off will be, like this. It will be something like this. Okay, it will be a blink interval time 2. Okay, it will be equal to 1. It means, just 1 plus off, it means one cycle. Okay, so if we just multiply it by 2, it will give us, one full cycle, right? And this time, now here we just defined where is it? Okay, this time that time, this variable current time that time, it's just give us the current time in seconds, and it's a floating point number that increases, continuously. So since this is the float, number, this time, that time, so I'm gonna use the modulo, operator. So, for example, I can here I can say, current time, so divided by blink interval. So, the modulo operator, it gives the remainder after division. So here, here we just divide current time, by the full blink period, I mean 1 second, and take the remainder. Okay, as time marches forward, the remainder cycle from 0 0.0 up to just under 1.0, then resets to 0 0.0 and repeats again. And this cycle will just repeat and repeat and repeat. So, this remainder represents where we are within the current blink cycle. Just for example, at t equal, for example, 0 0.2 seconds, the remainder will be 0 0.2. At 0.7 seconds, the remainder will be 0.7. And at 1.2 seconds, for example, the remainder will be 0.2 again, because 1.2% 1.0 equals to 0.2. So remainder is a sawtooth wave that goes from 0 to 1 repeatedly. Okay, so now we need to compare that remainder to our blink interval. Okay, we need to just compare it with our blink interval. Okay, with this blink interval. Okay, let me show you our this blink interval. So we have to compare it with this. So how we can do that? I can say if this if the remainder is less than blink interval, okay, right? So here what did I do with this a greater than blink interval? It means now we as I told you, compare the remainder to blink interval, I mean to 0.5 seconds. If the remainder is less than 0.5, the condition is true, and if it's greater or equal to 0.5, it is false. Now just let me just explain what happens over one full cycle. From a remainder, let's just imagine that remainder is 0 0.02. From the 0 0.0 to 0 0.5, the condition is true. It means the LED should be on. And from 0 0.5 to 1.0, the condition is false, and it means the LED should be off. So at the moment a remainder crosses 0 0.5, the LED switches off. When a remainder reset to 0, it switches on again. This creates a perfect square wave with a 50% duty cycle. So now I'm gonna put all this formula into one variable. So when I want to use this formula, it will just be very easy when I just use that variable. I'm gonna call this variable this, like, for example, blink state. Okay, so blink state, right? If you can remember, we just defined this blink state here. See, blink state, we just defined it here. We said true. Okay, so I'm gonna just put this whole formula into this variable, the blink state. If you can just see here, you can remember we defined it here. Now we can just so after that the fire, it means we are in the fire state now. So now I can say fire state. So I'm gonna just let me show you here this function. So I'm gonna call the fire state function. So I'm gonna say fire state, open and close parentheses, but this time, in this state I have to give it the argument. Okay, so which argument? I'm gonna give it this argument. Okay, the blink state. All right. Okay, so now the last thing that we have to do is just to check if someone pressed the key. For example, now I'm gonna say the R key on our keyboard. If we check if the R key is pressed. So if so, we manually reset the system to safe state. We reset the last flame time, and we call the safe state mode. and we're gonna wait 0.5 seconds, for example, to debounce the key. But it depends, on you, how long you want to wait, but just 0.5 is enough. So I'm gonna just create it here. I'm gonna say if keyboard dot is pressed. Okay, so if this key will be R. Okay, so what gonna happen? So if you press R to reset, so I want to print a message first for the user to say system reset. Okay, and after that we want to go to the save state, so I'm gonna just call our system state, sorry, this function, the save the save state function. So I'm gonna say system state. First of all, I'm gonna say system state. I'm gonna say it will go to the save state. Okay, and I'm gonna just set last flame time again to none, and now it's time to call the save state function. Okay, so I'm gonna say save state, open and close parentheses, and at the end, as I told you, just we're gonna wait short period of time, like 0.5, for debouncing. Okay. So okay, this is it. And now, just at the end of all these all these loops, okay, now here, just we're gonna exit from this loop. Okay, yes, so we're gonna just add a short delay, because if we don't do that, the program will consume 100% of your CPU. Okay, so to prevent from that happen, if you can remember, we used to do this for all our previous programs. So I'm gonna say time that sleep, a very tiny, moment, 0.05. Okay, so that's it, guys. So now just we finished our try block. Okay, now it's time to create our except block. So I'm gonna say except, okay, keyboard interrupt. Now I'm gonna say I want to print a message for the user, like emergency shut down. Okay, emergency shutdown. So what's gonna happen? Save state. I'm gonna just call the save state function, save state, open and close parentheses, and I'm gonna just exit from my program. Okay, sorry, board dot exit. So if you press Ctrl C, we print this message, emergency shutdown. Call the save state to turn everything off, and we close the Arduino connection with this board dot exit. Okay, this ensure a safe exit, right? Okay, guys. So I think now the coding is finished, and I think nothing's left. Now we can just go and run our program and see if everything works properly. Okay. Okay, guys, now let's run our program and see what's gonna happen. Okay, I press the run button. Okay, we are waiting. All right. Okay, system safe, system ready, safe. Okay, everything works properly so far. Okay, now I'm gonna just use the lighter to just approach a little bit flame here. Okay, yes, it works perfectly, guys. See? So now the buzzer is on, and the LED, the red LED, is just blinking. And if you could hear, if you can see, now my the relay is also on. So you know, it depends if you if you connect it to, like, you know, a DC motor or a fan or a sprinkler or everything, it just starts, you know, for example, uh, driving the motor or whatever you want. Okay, now let's just press the R button on our keyboard and see what's gonna happen. Okay, system reset, and just there's a it shows an error. Let's see what that error is. Time that time. No, sorry, it's just a mistake. Okay, so here I just set the time that why I said time that time, it's supposed to be time that sleep. Sorry guys, it should be time that sleep, not time that time, time that sleep. Okay, so let me just run our program one more time, okay, to see what's gonna happen. Okay, we are waiting. Okay, system ready, safe, and let me just okay, we're wait. Okay, it's working properly, and now let me just press R on my keyboard. Okay, system reset, and again now it went to the safe mode. And again, if I just turn the light on, let's see what's gonna happen. Yes. Okay, everything works perfectly, guys. So now let me press the R again. Okay, it's great, and Control C. Okay, emergency shutdown, and it exit from the program safely. Okay, guys, so as you can see, everything works perfectly, and hope you just liked the lesson and you enjoyed it. Please let me know if you have any question or if you have any doubt. See you in the next lesson.